All right, so I'm live and I want to talk about some of the stuff that Pragmatic AI Labs has been building, why we've been building it, and why we think 2026 is going to be the year of local, open source, portable, explainable models. And it's going to be doing this kind of work in Rust. So let's take a look at a few of the things here that are happening in this game on interactive.piml.com. So what's happening is this demo game has a portable model in the .apr format. This is from Aprender framework. What's interesting about this portable format is that this model explains exactly what it's doing in real time. So it says the ball direction, the prediction, the max speed, and this is something that is an explainable model that you can download. You can retrain it yourself. It's completely open source. There's no licensing. You can take this model and change it and actually add your own explainability metrics to it. You can see who created it and also trace the lineage as well. What also is nice about this .apr format is that it has the ability to run in a very tiny embedded environment. So if the internet turns off, you can still use this model. Additionally, what is interesting about this style is that you also can take advantage of specific chip instructions using SIMD, and you can also take advantage of GPUs. And there's one way to do it, and you can put this model inside of a binary as well and deploy it to anyone else. Now, let's take a look at how this was actually created. If we go to the Aprender framework, inside of here, you can see from Pragmatic AI Labs, we have a completely open source framework. This is how the model format works. You can actually go through and cargo install this yourself. And it's pretty simple to train your own models. You can use deep learning. You can do traditional machine learning. You could even do simulations like, for example, Monte Carlo simulations or traditional Bayesian statistics. All of this is inside of the Aprender framework, and you can actually export these models, which are tiny little models, and they also run as well on, again, scalar, SIMD, or GPU. So you can actually have a fully transparent pipeline where you build the model once and you deploy many, including to WebAssembly, which is how we built that game. Now, as a proof of concept to prove the kind of things that you can build, this is why the Hugar framework has been created. The idea here is that you can also build reusable, decomposable open source games. We're going to have the ability in a little bit to have a YAML file where you don't even have to be a software developer. You can change a game, you can change the model, you can change the structure of it, because again, this is pure Rust and it's open source, and you can actually deploy this locally. The internet can be turned off and you can actually run this inside of your browser. You can go to PIML Hugar yourself, download the Pong game. It's completely open source. The model is completely open source. And again, the idea here is that we're going to see a very different narrative to machine learning and MLOps in 2026. We've heard about Jupyter notebooks and slow Python code and bundling legacy C from the 1980s, but the future is going to be very different. In fact, it doesn't even need to involve corporations for MLOps. You can actually do these things yourself. You have complete ability to turn off the internet, train all of it without agents. You have total control with this small, lightweight format. And let's go ahead and end this session with a demo game here. Let's go ahead and take a click here at this demo. And another thing that we added just to show some of the cool things you can do is you can also stress test and see how performant this actually is inside of a browser environment. We also have other examples on the interactive.piml website of this model format. For example, doing real-time simulations like financial simulations or physics simulations. You can see, thousands of paths per second here. This simulation is extremely performant because, again, it's running a very tiny model that you yourself control. You can download the model. You can see right here, you can download the model yourself. We also have another example of shell autocomplete. Again, this is an example you can download from Aprender as well. And you can see here that we have millisecond level response inside of the browser. So the future of corporations telling you exactly how to train models. You have to use some kind of third-party software, or someone's hand waving about Python for MLOps. All of that actually doesn't need to exist anymore. You can take a look at the Aprender framework. You can actually run it yourself. It's all completely open source. And I guess the last thing I'll say is that if you want to take a look at PIML as well, we have lots of training where we teach you how to do these things on our platform. So thanks again for paying attention to us, and I'll talk to you soon.